For nearly 3 decades, Provinet Solutions has been providing solutions you can trust. Hello and welcome to today's webinar on network infrastructure and design. My name is Frank Mazuka and I am the marketing specialist here at Provinet Solutions. Before we begin, I would like to give you a brief snapshot of Provinet Solutions and introduce our presenters. At Provinet Solutions, our mission is unlocking the potential of technology. Mission drives what we do every single day, and for us, that mission is simple: unlocking the potential of technology. At Provinet, we don't manufacture any technology. We assist other organizations in planning, designing, implementing, and supporting technologies that are commercially available in order to help them maximize their investment in technology. We hear too often that organizations don't feel that they are leveraging the technology investments that they make, and that's disappointing. Technology is an incredible tool to help organizations do what they do better, faster, and smarter. And our mission is to help organizations put that tool to work for them in a meaningful way. To learn more, I invite you to visit us at www.provinet.com. Our presenters today are Tim, Provinet Solutions Architect, and Dale, Provinet Solutions Lead Engineer. Tim has been with Provinet for 16 years, and Dale has been with Provinet for 8 years. Both have extensive knowledge on network infrastructure and design and have been leading projects for many of our clients. If you have any questions today, please click on the questions icon and Tim and Dale will be happy to answer them when the webinar is concluded. Thank you again for joining us. Now here's Tim and Dale.
Welcome to Provinet's webinar. I've got Tim Baker today, Provinet's Enterprise Architect, and I'm Dale Enikenberg, Provinet's Lead Systems Engineer. Today we're going to be talking about network infrastructure and design. So Tim, when we're talking about network and infrastructure and design, I find it's best to start all the way from the internet and just work our way in. So talking from network topology and the internet specifically, is there anything we need to be considering when we're discussing internet?
Yeah, I think when we talk about internet connections, we really want to look at the applications that we're going to be using. You know, where is our data located? Is it in the cloud? Is it internally? Do we have multiple sites in our organization that we need to think about? And really use that to define what our requirements are. So for most senior living organizations, we're going to want to make sure that we have at least 2 internet connections. We want to make sure that they're fast enough for what we intend to do, you know. Make sure that when our staff is using those connections, you know, that they're speedy and that it doesn't inhibit the use of the software applications that we're using. We want to make sure that's reliable. That's why we want at least 2 connections. So that way, you know, if one of the providers is having a bad day and that connection gets cut or is down for any reason, that we have another connection that can take up that load and support our organization during that time frame. We also want to look at, you know, if we have multiple sites, you know, how are we going to connect to those other sites? You know, is that going to be through VPN tunnels in which our firewall and gateway devices establish those connections? Or are we going to work with our providers to actually give us what would be like an MPLS or a software-defined WAN type infrastructure that's really going to connect all of our different sites together, so that way, you know, for data and files and whatnot that needs communication between those sites, that will be there.
So working from our internet connections, if we kind of come back in a little bit closer to the network, we bump into our firewall and our routing devices. So can you kind of go into what we're looking for in the way of a firewall device and what we would want to see and anything we would want to avoid?
Sure, I typically refer those as gateways. You know, the primary function of that gateway is for communication between, you know, what we would consider kind of the outside world or the wide area network and kind of our inside world or our local area network. So that's what provides that connection, and that's called routing. Just as important, if not more important, is security. So in a world of constant threats, you know, we really want to make sure that we're using what's called a next generation firewall. That firewall, while also giving us that connectivity between the outside world and if we're using VPN connections to our other sites, it's also inspecting all of that traffic as it flows and it traverses that device. So we want to make sure that we're inspecting that traffic to make sure it doesn't have viruses or other kinds of malware. Some firewall gateways also will inspect email traffic. We really want to try to stop that malicious activity before it enters into our local area network. We don't want a virus to get to a server or a workstation. Certainly we're going to take countermeasures there as well. But if we can protect that at the edge of our network, that's the best way to stop that. And so next generation firewalls are specifically built to do that. And any organization today should be using that technology to better secure and manage their networks.
Now, when we're sizing that firewall, we have to be mindful of a couple things. The biggest one likely being we're going to have this firewall for 3 to 5 years generally, so we have to kind of vision where our company's going. From there, we probably got to make sure that we're sizing this for where we're going to be in 3 to 5 years. And with the cloud, that gets a little interesting, doesn't it?
Yeah, there's a couple options there. Certainly, when you size a firewall, you want to look at the specs on that firewall, and you want to honestly discount those specs a fair amount. The various vendors use a common specification in order to size their firewalls. Unfortunately, that specification is a little bit misleading due to it looks at traffic that is not stateful, meaning that there's nothing tracking to make sure that message was delivered or not. That causes kind of a misrepresentation of the throughput of that firewall, because most of our connections nowadays are stateful connections. We have sessions that we need to make sure that all of that information is tracked and getting to the right place, or retransmitted if it's not. And that takes a significant load on that firewall. I tend to discount the specifications of that by 50% right off the bat. And then I look to the future and say, okay, more and more applications are going out to the cloud. I'm using, Netflix streaming, or my residents more likely are using Netflix streaming and other services like that, or voice calling, FaceTime, all of those sorts of things. They all rely on the cloud, and so I need to look out long term on, okay, if I expect to have this device for 5 years, what is a comfort level that I have with that device lasting that long. There are some models that I'll purchase where it's almost more like a rental type agreement where you rent that device and you have entitlement to use that, and that doesn't lock you into that device over a 5-year period. 2 years into that, you could say, hey, you know what, this device is smaller than what I need today, so let me get a different device, and really I'm just going to pay a different monthly payment for that. So that's another way to look at it as well, if you're looking to maybe future-proof a little bit, or maybe allocate budgetary dollars a little bit differently. That's also a model that a lot of communities have gone with.
So we'll bring this inside just a little bit farther. We've gone from the street to the door. Now let's actually go in the house. We get into our core networking switching. First of all, is there anything that you would describe for how to hook together your gateway and your core? And then what are we looking for in a core?
Sure. So our core network is really, the piece of the puzzle inside of our building that connects all the other devices. The core is where all that network traffic that we're generating, or our residents are generating, is going to pass through that point in order to get out to the internet or get to one of the servers in our server room. So when we look at core networking, we want it to be very reliable. That includes things like multiple power supplies in those network switches to make sure that if we lose power to something, we try to maintain that availability of that device. It also includes, battery backup equipment. We want multiple battery backups and separating out how we plug things in so that if one of those devices fail. It includes how we connect other switches, other firewalls, servers. The list, could be really anything, but plugging in multiple connections into multiple network switches, so that way, again, any device that may fail, which inevitably it will, doesn't take down our services that we keep up and running. Maybe we're slightly degraded, maybe we don't even notice that device failed at all, but we want to configure all of that equipment in a very redundant fashion, so that way it's extremely reliable.
Okay, so from there, we're in the core. Now we got to start getting to the edge. We're going to be more looking at the distribution part of the network. What are we looking for as far as connectivity there, and anything special about those switches we should be aware of?
So once we get out of the core, most communities will have, a central data closet or a server room inside the community, and then they have what we would call an IDF, or some other people might call it like a network closet, or several of them throughout the building. We call that, the edge switches. Inside those closets, first thing we want to make sure is that we have a good connection back to our core. That typically is going to consist of fiber optic cabling. Preferably that it will be something that is capable of 10 gigabit connectivity. So that would be your single mode fiber, or OM3 or OM4 multi-mode fiber. What that really gives us is a very fast connection back to our core switches, so that way, all that data and all those connections that we're aggregating from our users is going over a very fast and reliable connection. We also want to have multiple of those connections back to the core. Again, it's all about redundancy. If something were to break, or what's called like a fiber optic transceiver, if one of those were to fail, and we still want to keep operating, certainly we're going to fix that, but if we can maintain operations while that failure has occurred, certainly our end users are going to be much happier and more productive for our community.
Yeah, with life safety and business critical systems running on this network, we have to constantly be thinking about the fact that we have to be moving data at all times. Outages are just not acceptable.
Exactly. We also have to take into account, what are the end applications, as you said, that could include, Wi-Fi access points plugging into those edge switches. It could be security cameras. It could be voice over IP telephones. There's just a huge variety of what that traffic is nowadays, and how that all connects back into that edge network. When we think about the Wi-Fi and the security cameras and the phones, we also power all of those devices through our edge switches. So we have to take into account what sort of power do all those devices need, and ensure that when we're planning this out, that we're also planning not only on the network needs of those devices, but also on the power needs of those devices, to make sure that we're able to provide that to the connection.
So let's talk about a couple of those devices that can be connected. We've got workstations, and of course at this point we would really want 1 gigabit connection to that, or are we to the point where we need to consider 10?
For most workstations today, it's going to be a 1 gigabit connection. It's going to be a copper cable, like a Cat5e or a Cat6 cable, probably more likely today, to those end devices, and that's suitable for today's networks.
So one of the other devices that we see a lot of is wireless access points. Mm-hmm. What's the connection like to those devices? And well, that kind of naturally goes into what do we got to be thinking about when we're thinking about wireless networks?
Sure. Most Wi-Fi access points today also use a Cat6 cable to the Wi-Fi access point that is placed throughout the community. More and more what we're seeing with 802.11ac and 802.11ax is the capability for those radios now to exceed that 1 gigabit standard that we've had for the last number of years. In that case, sometimes we can reuse the Cat 6 cabling that's there. And based off the distance, we can actually get 2.5 gig to that with certain switches and access points. In some instances, we could have 2 cables running back to that access point to where we leverage both of those cables to get over that 1 gigahertz threshold. And even in next generation, we might start seeing, doing some sort of 10 gig type cabling to support that. I would say that's a little bit down the road, but certainly the future will come someday where that will be a requirement.
You quoted 2 new standards there, the 802.11ac and AX. So as far as that's concerned, yeah, wireless is getting faster, so we have to think about that. But we do come back to our application needs of, do you really need 10 gigabytes of connection to the application yet? So while it's something we've got to plan for, I'd happen to agree completely that it's something that may be a little bit further out than your next refresh cycle. So let's talk about Wi-Fi though. So today how do you pick where to put your Wi-Fi access points in your ceiling or around your building?
So today's models for communities have largely changed over the last 5 years. In the past, we largely put our access points throughout hallways and common areas that were easy to access. We typically had drop ceilings that made running the cable relatively easy to do. And to be honest, that worked because our residents didn't have a whole lot of Wi-Fi devices. Our staff maybe carried a laptop or a smartphone, but the number of devices was very minimal. Senior living's changed a lot, and I believe this trend will continue substantially in the next coming 5 years. The number of devices that a resident brings in has exploded. Today that resident has 1 or 2 smartphones. They probably have an iPad or some other sort of tablet.
Apple TV,
an Apple TV, Roku,
personal assistant, an Amazon Echo, Google Home. Yeah, no, you could be looking at 5-6 devices for just one resident.
Easily. And nothing's worse from a standpoint of bringing in a resident, telling them how great your community is, and then oh yeah, and our community has Wi-Fi. The resident moves in and they have all these devices and they don't work very well. It's very frustrating for both the resident but also the staff that is in charge of making sure that resident has a good experience inside your community. So modern Wi-Fi is really designed around a 5 gigahertz standard. What that really means is your access points need to be brought closer to where the residents are actually using their devices. That means those access points have to come out of the hallway and get placed inside the residential unit. Not only do we have to bring those devices or those access points closer to our client devices, but we also have to really consider what our client devices are, and really plan around what is the weakest client device out there. So that way we can properly tune the network and properly design it to that specification or that requirement. Most often that weakest device is going to be a smartphone or some sort of tablet, simply because they have smaller batteries and smaller antennas than the laptops that we carried 5-10 years ago.
Yeah, you can fit a much bigger much bigger antenna in a laptop than you can in a little Roku stick that plugs into the back of my TV. Yeah. So yeah, I'd imagine the powers are very different in between those two.
It's extremely different, and a properly deployed Wi-Fi, should be just as reliable as plugging a computer into a cable. I think, Ben, over the past, we've kind of thought, okay, Wi-Fi is just unreliable. Most of the time it'll work, but sometimes it just won't, and that's acceptable. I think modern Wi-Fi networks should be just as reliable as what we've seen with cable over the years, and a large part of why it hasn't been is because we haven't defined our requirements well in the past, or adjusted those requirements as our use of that type of network infrastructure has changed over the years.
So we've been talking a lot about residents on the network and also having users on the network, employees. That brings up a big question of security and how do you have control over that?
That's a very good point. So first thing is we kind of have to define buckets, I'll call them, on the network. The technical term typically is VLANs. So what we do is we say, okay, we have these different types of users with these rough types of devices. So our typical scenario is going to be, well, we have staff that are using company-owned assets that we have a lot of control over those assets and what antivirus is on them and really, you name it, we know those devices very well.
We control those devices.
We control those devices. We also have staff that bring in their own devices. They bring in their personal cell phones and they want to connect it to the Wi-Fi network. So those are two areas, and we want to put those in two different buckets to control what they can access from those devices. We also have residents. So residents are going to bring in all of their devices, and we need to put those into a bucket. We also have to consider, okay, if I have 200 residents and I put them all into the same bucket, well, what if Mrs. Smith goes in and prints to your printer, Dale?
Yeah.
Or streams something to your TV? That's not necessarily desirable either. So we call that micro-segmentation, where we want to segment out each resident so that they can have full communication between their own devices, but not necessarily impact the devices of other residents. Our other main user is going to be guests. That could be a contractor that's coming in, that could be a family member, or whatnot. So we want to look at those guests and we want to give them some access out to the internet to facilitate what they need. But we also kind of want to be able to identify who they are. Are they a contractor? Are they a family member? And most often we look at doing that by, let's say, an email address or a cell phone number or using some sort of their Facebook login or some way that we can have a reasonable means to identify who they are.
So we've got a lot of different players in our network that all have different roles. What's the trick to keeping them all separate, but yet keeping it that way you've got everybody that should be together in the right spots and everybody that shouldn't be, well, they're separated out?
Sure. So we call that NAC for short, or Network Access Control. Really what that is it's a software solution that integrates into your network switches and your Wi-Fi and all of those things, and it really looks at the who, what, when, where, and why. So who is that user? Are they logging into our network with an Active Directory login, one that we use to log into our Windows computers in it? Now we know who that is. Are they logging in to a resident? Have we given them a unique username and password so that way we can identify what bucket they belong into? Or are they a guest? We look at the who and we say, okay, let's have them input their cell phone number, and we're going to actually text them back a password so that way we can verify at least a phone number associated with that person. Or again, we could do the same thing with Facebook logins or email addresses, simply just giving them a means where we can know who they are to a certain extent. Then we look at the what. What device are they using? Is it a laptop? Is it an iPad? Is it you name the device.
An Xbox.
Exactly. If it's a laptop, is that a company-owned asset, or is it the employee's own personal device? That could make a very big difference into which bucket we want to give that. Maybe a staff member on a company-owned asset should be able to get to anything and everything they want. But maybe if it's their own personal
servers and all the enterprise applications, but if it's their own personal, I don't control the antivirus on that. I don't know what security patches have been put on that. That's a big danger to us as a network. So we got to be careful about what they can get to.
Yeah. So we typically want to put them into a different bucket and put rules around that bucket that say, they can only get to these specific things. Or I can even say, I'm going to look at what antivirus you have and whether it's up to date and all of that. And if it doesn't meet my requirements that I've set forth, I'm gonna restrict you even further until that gets resolved. Where are they connecting to us? So are they coming in through Wi-Fi? Are they coming in through a network port? Maybe, at my nurse station, yeah, they should have this rule set, but maybe if it's in the conference room, it should have a different rule set. I can look at that. And then when? Maybe during business hours, it should be this rule. And off hours, it should be that rule. I mean, we can look at all of those different items separately or together and make different decisions on how they should connect to the network and what they should have access to. It's very powerful with network access control to be able to do that.
I'm hearing a lot of power, but as we all know, with a lot of power comes a lot of configuration, a lot of work to set up. So I've got a feeling this is a very large undertaking to do something in the line of a network access control. Is that roughly correct? What does it take to do?
It is a bit of a process. The first thing that really is most important is to establish what are our requirements. What is our expectation on what we want to allow people to access? And then most organizations are going to look at that and they're going to prioritize it. They'll typically start with Wi-Fi and they'll say, okay, I've given all this access to Wi-Fi and let's start there and let's start working our policies into Wi-Fi. And once they have a reasonable comfort with that's working, then they're going to look at the wired portion of the network and they're going to say, okay, let's bring in connections that are plugging in and let's do the same thing and work through those rule sets. As you do that, stage by stage by stage, you're kind of just tightening each little step a little bit further, and ultimately you get a very secure network. But it does take time, and even after the fact, we're still going to see new devices show up, whether that be, who knows what the next IoT device will be. But we can keep kind of defining our policies beyond that. So it's not something that you're going to set up and forget about per se. It will kind of require some continual maintenance and some continual oversight.
So talking about continual maintenance, when we're discussing these wireless options and all this networking equipment we're putting in our firewalls, what should we be aware of for that administration that we should be looking for daily, quarterly, monthly, as we're going along?
I think we really want to look at having the people with the right tool sets to be able to administer that. Just like our workstations are going to need Windows patch management and constant antivirus updates and things like that. Largely we can automate a lot of that, but we still need the people and the staff behind that understand the technology, that can advise you well on maybe different risks that they see or different areas where improvement might be needed. There's so many tools out there that make IT great today. Things like remote management and monitoring to know that all my workstations have current Windows updates on them. They're all running a current version of an antivirus software, and if there is a problem with that device, whether it be a hardware failure or some sort of connectivity issue, all of that stuff can alert me and the right staff to address the issue, rather than waiting for something to break completely to where I have a staff member that's unable to do their job because the technology's not working.
We talked a lot about redundancy, and the only catch to redundancy is they can hide problems. So we need to make sure that we've got those appropriate safeguards in place, that when the redundancy does fail, we're aware of it before our staff members, our users, our residents are aware of it, and then we can quickly resolve those problems without anybody experiencing an outage. That's really the goal here. The dream is make it so that way something can break and nobody knows anything happened.
Yeah, it's all about keeping the end users working for productivity reasons for our staff, but also to make sure that the residents and the guests that come into our community have a positive experience. Ultimately, they're the ones that keep the doors open to our communities, and we want to make sure that anything and everything that we can do to make their experience positive reflects well on our community and the word of mouth that so quickly travels.
Oh yeah, we really know how quick. If you've got one user with a problem, all of a sudden you'll get lots of calls. But being able to control the networks that way, you don't have that starting problem is a big thing. So thank you for watching ProbNet's webinar on network infrastructure. If you have any questions at this point, please post them in the chat. Otherwise, you can find more information at www.probnet.com. So thanks for joining us.